This is the third experiment. Name of the experiment is heat transfer through pin. Aim to determine the temperature distribution along the given pin and efficiency and effectiveness of the pin under forced convection conditions. So these are the specifications. The diameter of the pin is 20 mm and the length of the pin is 120 mm. Here we are going to determine effectiveness of the pin, efficiency of the pin and temperature distribution along the given length of the pin. Okay, so these are the pin you can see here. There will be different types of pins. You can see here. In this, we are in our laboratory we are studying cylindrical fin. Cylindrical fin. Okay, so this is our experimental setup. What we have in our laboratory. So first I will name the parts of the experimental setup. First one is the air duct. Second one is the anemometer. Third one is the induced fan. Fourth one is the air outlet for a natural convection. Fifth is the temperature indicator. Sixth is the voltmeter reading. Seventh is the ammeter reading. Eighth is the heat input. By varying this knob you can vary the voltage and current. So next, ninth is the air blower switch here. Ninth is the air blower switch. 10th is the power switch. 11th is the electrical heater and 12th is the arrangement for a pin. Okay, 13th is the airflow sensor. Okay, now these all are the parts of the experimental setup of a pin. Okay, so now how to conduct the experiment? First we have to switch on the setup. Okay, then you switch on the heater, then you set the heat input by varying the voltage and current by rotating this knob. Okay, so now today I am doing forced convection heat transfer. To do that you have to switch on the air blower here. Now when you are switch on air blower, the air will enter here and it will exit here. Now there is an induced fan, it is going to suck the air will pass here through this test specimen and it will exit here now, and it is moving with certain force and velocity. Okay, after that you have to note down the velocity of the air by using an anemometer here. Now this is the anemometer. Okay, after that what you have to do? So now what you have done, you have switched on the electrical heater, you have set the voltage and current, and you note down the voltmeter reading. Then at least you leave it for at least 20 to 30 minutes. After that you have to take the reading. Okay, what are the readings you have to take? You have to take 3 thermocouples reading, I mean 3 temperature reading. Here you can see 3 thermocouples are placed on the surface of the metal pin here. Now the metal is aluminum. The metal what we are using here, it is a aluminum, that is aluminum pin. 3 thermocouples are mounted on the surface of the pin and 2 thermocouples for air temperatures. One is inlet air temperature, another one is outlet air temperature. That you can note it by you here. Now with the help of this knob you can determine the all temperature T1, T2, T3 up to T5. Okay, this is all temperature. You can take it from this temperature indicator. Okay, this is a tabular column here now. So what are the readings you have to take, that I will explain here now. Now I have taken 4 readings, but I will explain you one reading how to take the readings from this experimental setup. First, as I told you, anemometer reading, right? Anemometer reading, initially we have to take it from here, is it right? So next, voltage and current. As I told you, whenever you are giving heat input, I mean that you are varying the voltage and current. What is the voltage and current? That you have to take it into this column. Okay, next, air in T1 and T6, where T1 represents here, T1 represents air inlet temperature, T6 represents air outlet temperature. Here T6 is the for forced convection, whereas T5 represents that is pre-convection. You have to take care here now. T6 represents air outlet temperature for forced convection. T5 represents air outlet temperature for pre-convection. Here we are doing forced convection, so you have to take T1 and T6. T1 is air inlet temperature and T6 is air outlet temperature. After this, you have to I told you there will be 3 thermocouples, right? You have to take 3 temperatures from the aluminium metal pin here now. So that is T2, T3, T4. You can see here now. This is the electrical heater because that aluminium fin is one end is connected to electrical heater and one more another end is exposed to the atmospheric air here now. The first case, what I'm doing here, I'm doing for forced convection. That is a forced convection. You have to neglect this now. This is a forced convection. The same setup is used for forced as well as natural convection. But now I am doing forced convection. So this is a fin and temperature. Here it is a location 2. You can consider that is temperature 2, temperature 3 and temperature 4. Where temperature 1 represents what? Air inlet air temperature. Okay. So now you taken T2, T3, T4. Isn't it? These are all temperatures. T1, T6, T2, T3, T4 from the temperature indicator. From the temperature indicator by rotating this knob. Once you got the value, right? So what I will do, I will try to explain you the test. I will try to do one specimen calculation for this first reading. Okay. T1 is 35.8, T6 is 38.2, T2 is 35.9, T3 is 104.2, T4 is 104.2. I will do calculation for this particular first reading. So now what are the readings, what are the calculations you have to do? You have to see here. First one, average temperature. How to calculate the average temperature? Average temperature of given fin is nothing but what here now? T2 plus T3 plus T4 divided by 3. You will get the average temperature. I got average temperature as 112.03 degrees Celsius. Whereas TA, that is what? Ambient temperature or air inlet temperature, that is equal to how much? 35.7 degree Celsius. Now once you know the TA and T average, what you have to do? You have to calculate the film temperature. What is film temperature here? TF is equal to T average. TF is equal to T average plus TA divided by 2. You will get the film temperature. That film temperature is 73.86. You can take it as a 74 degrees Celsius. Once you know the film temperature, what you have to do? You have to take the properties of the air from the data handbook. Is it right? So what is the density of air at 74 degrees Celsius? That is 1.017 kg per meter cube. Kinematic viscosity will be 20.488 into 10 to the power of minus 6 meter square per second. Prandtl number is 0.6932 and kinematic then thermal conductivity of air is 0.02998 watt per meter cube, watt per meter Kelvin. These are the properties of the air at 74 degrees Celsius. Here it is a 73.86 degrees Celsius, right? Round it as a 74 degrees Celsius. Now, once you taken the properties of the air from the data handbook, that too from page number 34 from your data handbook. Okay, later you have to calculate the Reynolds number here now, because air is moving with certain velocity. So when there is a velocity, then I have to calculate the Reynolds number here now. What is the equation for Reynolds number? Reynolds number is equal to RE is equal to VE divided by kinematic viscosity. What is velocity? Velocity is equal to 2.1 meter per second. That you have taken from the anemometer reading. That is 2.1. Where it is anemometer? Here. From this anemometer, you got the value of the velocity of the air is 2.1 meter per second. That is a constant. Okay. So now what you have to do? You have to substitute that values. That is 2.1. Then diameter of the pin, as I told you, the diameter of the pin is 20 mm. The diameter of the pin is 20 mm and length is 120 mm. That you have to substitute here now. Okay. So now diameter is equal to 20 mm they have given, convert it into meter, then it becomes 20 into 10 to the power of minus 3 divided by kinematic viscosity. That kinematic viscosity is 20.48 into 10 to the power of minus 6. Substitute, you will get Reynolds number. You will get Reynolds number as 2049. 2049. You will get the Reynolds number. After this, you have to calculate the Nusselt number here now. What is the equation for Nusselt number? you have to refer phase number 116 in your data input. You will get an equation like that. Nu is equal to C into Re to the power of M Prandtl number, that is PR to the power of 0.33. You can take this equation or you can take this equation. So what I will do, I will go with this equation from the data input what I have taken. So now here, so to calculate the result number, I should need C value, I should need M values. Is it right? Because REA value calculated, Prandtl number you have taken it from the data input. Okay, the only unknowns are here C and M. These are the constant. These value you have to take it from the data input itself based on the Reynolds number. So based on the Reynolds number, you refer your data input, you will get C is equal to 0.683, M is equal to 0.466. Now once you know the value of C and M, you substitute in this main equation, because RE Prandtl number, all values you already know. Then substitute all values in this equation, we will get result number as 21.12. Once result number is calculated, then you can easily determine the heat transfer coefficient theoretically. What is the equation? What is the heat convective transfer coefficient equation by theoretical method? You can see here now. That is H is equal to Nu into Ka divided by D, because the fin is horizontally placed, that is D here. Okay, now result number, now what I will do, I will substitute the values here. Result number is 21.12. Then thermal conductivity of air is 0.02929988, that I have substituted here. Then D is what? Diameter of the pin, that is 20 mm is there, converted into meter by multiplying 10 to the power of -3. Then you will get convective heat transfer coefficient as 31.658 watt per meter square Kelvin. Once you know the value of convective transfer coefficient, then you can calculate effectiveness and efficiency of the fin. That I will explain next. Okay, so now after this you have to calculate the perimeter of the fin. What is the formula for perimeter of the fin? That is P is equal to 5 into D, where D is nothing but what, as I told you, that is the diameter of the fin, that is 20 mm, converted into meter and multiply with 5. Then what will happen? The perimeter will become 0.0628 meter. Finally you have to put answer in box as P is equal to, capital P is equal to 0.0628 meter. After this you have to calculate the cross-sectional area of the fin. Okay, the diameter of the fin already you know, right? How to calculate the cross-sectional area? We know the formula. What is that? A is equal to 5/4 into D square, where D is equal to what? 0.02. Substitute and get the area for the cross-sectional area for the fin here now. Now it is cross-sectional area for the fin is 3.1416 into 10 to the power of -4 meter square. Okay, once you know the value of A, then you can easily calculate M value. M is nothing but what here? M is equal to square root of HP divided by KFA. K suffix F into A. That is equal to H. What is H here? H is already calculated here, 31.656. Substitute here. Then P is what? Perimeter. That also already calculated here. Substitute and divided by thermal conductivity of the fin actually. What material we are using for fin? As I told you, aluminum. What is the thermal conductivity for aluminum? That is constant, that is 204 into, next area is what? Already we calculated, cross-sectional area for the fin is 3.1416 into 10 to the power of -4. Substitute all the values in this equation, you will get M is equal to 5.569. Okay. Thereafter you have to calculate the heat transfer with pin. Okay, how to calculate the heat transfer with pin? We have an equation, that is K into A into M into delta T tan hyperbolic ML. Okay, what is K here now? Again, K is nothing but thermal conductivity of the aluminum, because we are using aluminum fin, that is 204. A is nothing but what? Already we calculated 3.14 into this much into 10 to the power of -4. Okay, multiply. Next M you already calculated, that is 5.569. Substitute here. Next, what is tan hyperbolica? Tan hyperbolic you have to keep as it is. So tan hyperbolic, sorry, next one more term is there, that is change in temperature. Change in temperature is nothing but what here now? Here change in temperature is, you can take it here. See here, change in temperature, that is 112 minus 35.7. How it is? You can see here itself now. 112.03 minus 35.7. Okay. Now after that you have to write tan hyperbolic as it is. Then m is nothing but, it is a small m actually. Small m is already we calculated, that is 5.569 into, then L represents here length of the given fin. The length of the given fin is 120 mm. Convert that 120 mm into meter, then it becomes 0.12. Now you do the calculation, simplify it. You will get heat transfer with fin is equal to 15.905 watts. 15.905 watts. After this, you can calculate heat transfer without fin. What is the formula? Here, the formula for heat transfer without fin is equal to HA into M into delta T. H is nothing but what? Convective heat transfer coefficient, already we calculated here. Next, M, A is nothing but cross-sectional area, that also already calculated. M also you know. Next, change in temperature. That is, change in temperature is nothing but what here now? That is 11 T average minus TA. That is 112 minus 35.7. Now you will get heat transfer without fin is equal to 0.759 watt. Okay. Once it's over, then you can easily calculate the effectiveness, because effectiveness is the ratio of heat transfer with fin to the heat transfer without fin. Now heat transfer with fin is equal to how much? We can see here now. Heat transfer without fin is equal to 15.905, whereas heat transfer without fin is 0.759 watt. Now what will happen now? Divide it, 15.905 divided by 0.7519, then it will become 20.95%. The effectiveness of the fin is 20.95%. Similarly, we can calculate efficiency. To calculate efficiency of the fin, we have formula, that is efficiency is equal to tan hyperbolic ml divided by ml. Tan hyperbolic m already calculated, that is 5.569 into length of the fin is equal to 0.12 in meter. Okay, divide by 5.569 into 0.12. Then you will get value as 0.87. That is nothing but what? Efficiency of the fin. Then what we have to do? We have to calculate the temperature distribution along the fin. What is the equation? That is Tx minus T1 divided by T1 minus T6 is equal to cos hyperbolic m into bracket L minus x divided by cos hyperbolic ml. So what I will do? I will try to calculate the temperature at point 3 here now. I will try to calculate the temperature at point 3. So how to calculate that? You can calculate it here now. So I will write equation. I don't know the value of T3 temperature at point 3. So I will write it as T3 minus TA divided by T2 minus TA. So now is equal to what will happen? Cos hyperbolic ml minus x divided by cos hyperbolic ml. Okay. After this, what you have to do? Substitute. What T3 is unknown, right? Leave it as it is now. T3 you don't know, so leave it as it is. TA is nothing but what? You already know it here, right? TA you know here, substitute, that is 30.57. Then T2 also you know here. T2 also you know here, 30.9. Okay, so 30.9. Okay, substitute. Okay, now cos hyperbolic m is nothing but what? 5.569 into L is 0.12 minus x is nothing but what? I want at distance, right? At distance 0. At center, right? If it is a 180, if it is a 120 mm, if I want temperature at this particular point, that means what? Total length of the aluminum, total length of the given metal fin is 120. Then if I want a temperature distribution at exactly at the center, then it becomes what? 0. The x becomes what? 0.0, half. Is it right? Half of that 120 mm. That is 0.06 in meter. Okay, x, and substitute 0.06. Okay, divided by cos hyperbolic m into L here now. Here L represents total length of the aluminum fin. Substitute, you will get T3 is equal to 113.74 degrees Celsius. That means what? It indicates a temperature at point at particular this point is 113.74 degrees Celsius. This is the temperature distribution at particular point. That point. Okay, so now after this, what you have to do? Finally you have to put the result here. Now you have to write the result as efficiency and effectiveness of fin is 87% and 20.95%. After that you have to draw the graph, temperature vertical and length horizontal, and you have to draw the graph and you have to finish. Okay, this completes your pin experiments by forced convection.